My name is Neil Johnson, and this is my senior project presentation. My senior project is to develop a more efficient manufacturing process for the construction of spiral ribbon lathes. I was prompted by Holmgren Enterprises to develop a new process or mechanism for the construction of spiral ribbon lathes because of the inefficiencies in the current process of lathe production. The bottleneck for the process needed to be automated or assisted mechanically, because it caused the cycle time to be as long as 5 hours. In addition to the long cycle time, each lathe required an exhausting amount of tedious movements, which, for the long durations that the lathe manufacturing process requires, can cause carpal tunnel symptoms to appear after a production run. Because of the inefficient process and suffering of the workers, a new manufacturing process or assisting mechanism needs to be implemented. Lathes are typically worn during graduation ceremonies of every grade level. There are many types of lathes, such as flower lathes, candy lathes, and ribbon lathes. Seasonal demand for lathes peak around graduation ceremony times, which are around mid-June. Because of the surge in demand, it is difficult to anticipate the number of lathes needed to be produced for a certain production period. Spiral ribbon lathes are not as simple to make as typical flower or candy lathes, where the cycle time can be less than an hour per unit. Because of the nature of the ribbon material, it is difficult for mechanisms and robots to handle. Therefore, current methods for ribbon lathe manufacturing use manual labor and have extremely long cycle times. From my literature review, I've discovered that modern sewing machines do not and cannot create the necessary stitching patterns because of the interlocking stitching that it produces. Modern sewing machines catch the top thread and weaves it with another to create a chain within the fabric to bond it together. This does not allow for the fabric to be slid across the thread, which is necessary for spiral ribbon lathes. As seen here, Moray's running stitch machine has the potential for creating the desired running stitch, but needs to be altered for mass production. The problem that still needs to be solved is how to create a running stitch mechanism or automated machine, the ideas of how to spiral the lathe automatically, and ideas to automate the process altogether. Alternate lathe designs could be an addition to the lathe manufacturing process, because for different lathes there would be a different mechanism or process which needs to be done, and having the process or mechanism be able to switch between designs would be most favorable. These ideas will be explored by first brainstorming, then prototyping, then testing the prototypes and analyzing the results before implementation.